I actually can't. What?
Hey, Grayson. How are you?
Oh wait, this is connected. Hold on. Wait, no.
Grayson, can you hear me? Grayson,
What?
can you hear me?
Oh yeah, but it's
Uh,
like I can't turn my camera off or mute my microphone or anything. It's like weird.
oh, really?
I could cover it, but like so now my microphone's like continuously turned on. Can't mute it. I'm so confused.
Yeah, I wonder what happened. So you don't have that little pull down thing at the top? There's like a little pull down menu at the very top that allows you to do that
Yeah,
stuff.
I have that, but it literally won't let me click it. Like I
Oh,
found a
wow.
I found a way to mute myself, but it's different way, but my camera's still on.
Oh, it's okay. We don't mind seeing your smiling bright face in Math Lab.
Probably do. I could like cover it up or something.
No, you don't have to cover it up. Actually, I won't be able to see your smiling bright face because once I'm on the worksheet, I can't see anything.
Oh.
I can't see the group chat, nor can I see
Yeah,
who
but other
all is
people are
on.
on here.
Yeah, but I'm sure they don't mind that Grayson, your
Or
smiling
we could
face.
just like like
Oh, look at the sweet puppy. All right. Okay, just a reminder. Hey, Eli, just want to apologize to you that I only gave you the class notes page and I did get it emailed. Hoping that you got the homework and the notes about that you only have to do the odd problems for the class notes, as well as we're only doing the odd problems on both of the worksheets. So it equates to being about the same number of problems. It's just they're all the same factoring that we've been doing for the last 6 to 8 weeks. So I was just going to do that in one day. We're just going to do a variety of solving these quadratic equations by factoring, because basically the only difference is that you're just adding that zero at the end, and the things that we have been factoring in the past are just expressions, and these are equations. So there's really virtually no difference. We're going to approach them the same exact way as we did when we're factoring. We're just one additional step after that to solve each little factor, and that's it. So you'll see that in the first few problems that we do. Um, so I'll get started so you'll see a little bit better idea of exactly what I mean by that. Um, all right, so for number one, we're looking for two factors that multiply together to give us 12, that when we add them, give us 7. So two factors that multiply to give us 12, that when we add them, give us a positive 7. So that's going to be positive 4 and positive 3. So x plus 4, x plus 3 equals 0. X plus 4 equals 0. So you take each little factor. I put some K cups in the bottom drawer of the Keurig.
So you make coffee?
Oh yeah, there's coffee in the coffee pot too. Sorry guys. And then you take each little factor, like the x plus 4, x plus 3, and now you'll actually solve for x. So x equals negative 4 over here, and then, oops, and then x equals -3 here. And then you write your answers as a solution set. And yes, my brackets are not very attractive. So that's the answer for number 1. So basically, you're factoring just like we did in Unit 8 for the last 6 weeks, but then you're taking each one of those little factors and setting it equal to 0 and solving. And what these results give us, remember on Friday when we talked about when we solve a quadratic equation, those are solving, solutions, roots, x-intercepts, zeros. Those are all the same name for where this quadratic crosses the x-axis when you're graphing it. So number 3, I'm looking for 2 factors that multiply to give me a -30, that when I combine them, give me a -1. So that's going to be a -6 and a +5. Because I know the bigger of the 2 factors has to be negative. Because when you take the difference of a negative number and a positive number, or when you combine a negative number and a positive number, you find the difference and give the sign of the higher one. So that's going to be x -6, x +5. And it stays equal to 0. And now the next step is to take each little tiny expression and set it individually equal to 0 and solve for x. And this part is just a repeat of pre-algebra because these are one-step equations, very simple one-step equations. So I have a solution set of 6 and -5. Love you. Be careful. Love you, Grace. Y'all be careful. So I have a solution set of -5, 6. All right, on number 5, this one isn't in standard form. Standard form, I'm going to borrow some space over here on number 6 and cross that out since we won't be doing number 6, just to write down and remind everybody in math lab what standard form looks like. Standard form looks like ax squared plus bx plus c equals 0. So I have to have a squared term first, a single term in the middle, like the bx. So x doesn't have an exponent in that middle term. And then my constant is the third and final term. So I want a squared term first, an x term with no variable second, and a constant last. Now, sometimes one of these might actually be missing, and that's okay. But when you have an x squared term and an x with an exponent of 1, you want to make sure before you start solving that it's in this form right here, this standard form. That's the very first thing that you want to do. You really can't proceed to the next step of factoring until it's in this form. So in order to get it in that form, I can't just simply move this 9x. I have to use my algebra rules in order to move it to the other side. So that means I use the inverse operation to move it to the other side of the equal sign. And 9x is being added, or it's assumed positive, if you will, on this right side of the equal sign. So the inverse operation of addition or positive is negative or minus. So I'm going to subtract 9x from both sides of this equation, And then I will be able to put this now in standard form by bringing this 9x down. And this would eliminate it from this side, leaving a 0. So now I have, this is in standard form. So it looks like this. So now I'm looking for two factors that multiply together to give me a -10.
What? I don't know what's going on. It might. I think I'm muted, but
No, you're not muted. We can hear you.
I'm not.
No.
Oh.
That add together to give you a -9. If you're still talking, I can't hear you now, Grayson. So whatever you did might have worked. So two factors that multiply together to give you a -10, that when you combine them give you a -9. That would be -10 and +1. Because -10 times +1 gives me a -10. And then when I add those two together, they give me a -9. So my two factors are x minus 10, x plus 1 equals 0. So now I'll set each of my little factors equal to 0 and solve for x. Once again, these are just very simple pre-algebra types of problems. And I have a solution set of -1, 10. All right, once again, number 7 is not in standard form. I have two x terms. I have one on the left and one on the right. So I want to combine those terms so I can get it in this form right here. Because I only want one ax squared term. I only want one bx term and only one constant. I cannot factor until I get it in that form. So in order to combine these two terms, I have to do the inverse operation of the operation on this 7x, which is a positive. So that's going to be, I'm going to subtract 7x from both sides. So now I have x squared minus 10x. And when you're actually combining terms from the right side to the left side, it's really a good idea, if at all possible, to line it up where you're combining it. So that's why I lined up this minus 7x right underneath that 3x term, because those are the terms that I'm combining. So keeping your work neat and showing all of your work is very, very important when doing these problems. So now I'm looking for two terms that multiply together to give me a positive 16 that when I combine them, give me a -10. Positive 16, -10. So I'm thinking of all the factors of 16. 16 and 1, 8 and 2. Well, 8 and 2 certainly add up to be 10. But a -10, that means that both are going to have to be negative. So I've got an x minus 8 and an x minus 2. Two negatives multiplied together give you a positive. So that's how I got my factors. And now I'll take each small factor and set it equal to 0 and do a simple algebra problem, pre-algebra problem, really. X equals 8. X minus 2 equals 0. X equals 2. So I have a solution set of 2, 8. All right, now this time on number 9, I have two things to combine. I've got an X term here and a constant that needs to go to the left-hand side. So I'm going to subtract 3x from both sides. And if you were inclined, yes, you can do this at the same time. But for the sake of Math Lab and people who might not do this at the same time, sorry about that. I'm going to do it one step at a time, at least on the first one. So I would add 1 to both sides now that I've combined my x terms. So now I've got it in standard form and I can begin the factoring portion. So I'm looking for two terms that multiply together to give me a negative 45, that when I combine them, give me a negative 4.
Mrs. Sparks, haven't we
Yes.
done some like math unit that's similar to this kind of stuff?
Yes, that's exactly what I've been.
Seems similar-ish.
Well, yes, that's exactly what I've been saying. All of this is what we just finished. This is factoring. Remember, we just finished a whole unit on factoring. That's why I said all this is we're adding one little step to the factoring by taking those factors and setting them equal to 0. That's all we're doing. There's really, for this particular piece, you're absolutely right, Grayson. There's really no difference. Yes, this is all.
We've done this exact thing before. We're just sticking a 0 in there.
Yep, that's it. That's what I've been saying this whole time. It's really not that, it's not that hard. You just have to make sure it's in standard form and then you're factoring. Remember last unit when I told you guys that factoring is kind of like your new multiplication? Basically, like, we learn to add and subtract, and then we learn to multiply. Factoring is kind of like the multiplication and addition and subtraction of high school math. This is a skill that you will be using. You'll use this in geometry. You'll use this in Algebra 2, and you'll continue to use this in pre-calc or Algebra 3, wherever you go. And actually, I can't remember if you use it in stats or not, but you might. So pretty much the rest of your math career, you're going to be doing something where factoring will be the basis. So yes, you're absolutely right. What you're recognizing is factoring. And yes, we spent 6 to 8 weeks factoring.
Okay, because parts of this seem pretty easy.
Well, good. I'm so glad to hear that. That makes me really happy.
Well, that is at least watching you do it. Like, I don't know, on the quiz, I'm not sure how that's going to work. But
I understand. I understand. It's that whole blank test thing. It's like, I really did understand this before. I get it. I've experienced it myself. Or when you're required to write an essay. Oops. So yeah. So now I've factored, which is the part that Grayson should be eerily familiar to you. Now this part where you're taking each little factor and setting it equal to 0. And this is just a little minor algebra problem here, pre-algebra problem. This part's not a big deal really either. This should be pretty similar as well. You've been doing this a hot minute. All right, now we have a solution set of x equals -5, 9. And when I say we have a solution set, what I mean, remember on Friday where we learned that the solutions are the x-intercepts, are the zeros, are the roots to a quadratic equation. And that is where, if I were to graph that parabola, where it would cross the x-axis. So that's what we're solving for. So we could literally find 3 points, really, with just an equation by finding the x-intercepts and the vertex with a given equation for a quadratic. So now on number 11, we're going to combine like terms. So I'm going to subtract x squared from both sides. So that's going to give me x squared minus 7x plus 4 equals -8. Always watch your signs, ladies and gentlemen. They can definitely get you into some trouble. Plus 8, because we've got to get this thing in standard form, and leaving a 0 on our right side. So now I'm looking for two factors that multiply together to give me a positive 12, that when I add them, give me a -7. Okay, so I know that both factors are going to be negative, because the only way I can have a positive multiplication problem and a negative addition problem is to have two negatives. So that's going to be -4 and -3. So my factors are x minus 4, x minus 3 equals 0. So now I'll do my individual solving. So x equals 4, because I would add 4 to both sides, and x equals 3, because I would add 3 to both sides. So now I have a solution set of 3, 4. And you'll notice I am trying to put these in chronological order, because I usually in a solution set prefer to put my answers in order of least to greatest. Least to greatest is usually what you do. Okay, number 13 changes courses just a little bit, but we're still going to factor. There's no terms to combine. There's no like terms. I don't have any on the right that I need to combine to the left. And there's no like terms that need to be combined on the left-hand side. But I only have a 2-term equation here. So what I'm going to do is either notice, is it a difference of squares, which it's not, because my operation is addition. So what the next thing I'm going to look for is a greatest common factor. What is the greatest common factor here? Anybody tell me?
1? No. Wait. Is it 1 or is it 0?
Well, 1 is a factor, but there's another one. Remember, factors can be variables.
Oh, x.
Yes. So
Yeah.
if I factor out an x, what am I going to have left?
3 equals 0, maybe?
When I take an x out of x squared, what's left?
Oh, just x.
When I take an x out of 3, what's left?
3.
I mean, when I take an x out of 3x, there you go, 3. So there are my two factors. Do not let simple problems throw you back, okay? Do not let simple problems like that give you a step back. Don't, you can still factor those, all right? Everybody understand that? Just because it's just a greatest common factor, we still have two factors. So now I'm going to take each factor and set it equal to 0. So that one's already done, isn't it? So when I set x equal to 0, x is equal to 0. Well, that tells me that's going to go through 0, or the origin, really. And then x plus 3 equals 0. Subtract 3 from both sides, and x equals -3. So I have a solution set of -3, 0.
Miss Sparks, your brackets look pretty good today.
Oh, thank you, Grayson. You're so sweet. You know, they're not too bad. They still need a little work, a little help. You can obviously tell Miss Sparks is not an artist for sure.
Mine could be worse.
I don't know. Oh, I was like, oh man. Every time I teach a math unit where I know solution sets are going to be a part, I get a little panicked, get a little fear. I'm not going to lie, just because. But so I really appreciate your kindness. That was really sweet, Grayson, because you know the struggle is real. All right, number 15. I've got an x on the right, so I need to combine that with my x on my left. And I'm going to subtract. And that's going to give me my 0 on my right that I'm looking for. And then 6x squared. And then minus 2x minus x is going to be minus 3x. So what is the greatest? Now, is there something that's a greatest common factor that I can factor out here for this one? What's the greatest common factor of 6x squared and 3x? The GCF. 6x squared and negative 3x. What would it be? What will go into both of those?
3.
I'll give you a hint. It's a letter and a number. Oh, yeah.
3x.
What'd you say? I'm sorry. 3x. Good job. That's it exactly. So 3x. And if I take a 3x out of 6x squared, what do I have left?
3x.
Try one more time. 3x out of 6x squared.
2x.
Yes, good job. 2x. And then if I divide 3x by 3x, what do I have left?
Negative x or -1?
-1. Good job, Grayson. -1. So these are my two factors for this one. So I set each one equal to 0. And if I divide both sides by 3, I still am going to have 0 here. So x equals 0. And then 2x minus 1 equals 0. Now this is a two-step algebra problem. So x equals 1/2. So my solution set is 0 and 1/2. All right. Number 17 is a special factoring situation. Do you remember what it is?
Miss Sparks, can you scroll up for just a second?
Yes. Hey, Mary Faith. I didn't
sorry.
click over to see who joined us. How are you today?
I'm good. How are you?
Good. Oh, hey, Roger. How are you today?
Good.
Good. And oh, Stephen, how are you? Eli left. How long ago did he leave? Does anybody know?
I'm not sure. He wasn't on when I joined.
Oh, okay.
I joined about 10 minutes ago.
Oh, okay. All right. Okay, does anybody know what number 17 is?
Is it
Special
difference of
factor.
squares?
Good job, Mary Faith. It is the difference of squares. So what's the square root of x squared?
X.
And the square root of 36?
6.
Uh-huh. So I'm going to write that as x plus 6, x minus 6. That's the special factoring situation of the difference of squares. So now I'll do exactly as I've done before. Set each small factor equal to 0. So I have a solution set of -6, 6.
This is becoming more clear now.
Oh, good. I'm so glad.
Yesterday I
A
was
lot of-
failing miserably at this.
Oh, well, a lot of times
Same.
practice does that, just seeing them worked out and continuing to process through, it definitely does that. And I'm so glad to hear that. Okay, once again, we need to get this in standard form, meaning we want everything on the left-hand side or the right-hand side. It really doesn't matter. It just means that you need to have a 0 on one side. But typically, we algebra students, because I'm always learning too, we kind of default to having our equation on the left and our 0 on the right, or our variable on the left and our solution on the right. So that's typically what I try to continue in that same pattern when working these. So we want to get everything to the left. So in order to do that, we have the inverse operation of the understood one here, which is going to be positive. So we're going to subtract 1 from both sides. And then we're going to end with 9x squared minus 1 equals 0. And Mary Faith, just like number 17, number 19 is a special factoring pattern. Can you tell me what it is? It's just the same as number 17. What was that one?
Oh, so it's different of squares?
Yes, it is also the difference of squares. So what is the square root of 9x squared?
3x.
It is. Good job. And the square root of 1?
1.
Good job. So we'll write it as 3x plus 1, 3x minus 1 equals 0. And then we'll take each individual factor and set it equal to 0 and solve. This is a two-step equation. So I have a solution set of negative 1/3, and 1/3. I'm going to give y'all a minute to make sure you get all of those copied down. And then we'll move on to more factoring. It's all the same thing. And I believe Grayson pointed it out. I don't know, Mary Faith, if you were here or not yet, but Grayson pointed out that basically this is very familiar to what we've been doing. You know, factoring, it will continue. This is one of those building blocks of math. It's a foundational concept. So very, very important. Just factor, and just remembering how to factor always will be a very advantageous to you for geometry and definitely algebra 2. There's a lot of times we revisit factoring a good bit. Okay, is everybody good with me switching to the other worksheet? Is there anybody that needs me to do anything else on this worksheet?
Miss Sparks, could you go back up to number 13?
Absolutely. Can you see it okay, baby?
Yes, ma'am.
I'll give you a minute to copy that down.
Okay.
Does that make sense, honey?
Yes, ma'am.
Okay. Sometimes those little simple ones throw people for a loop, I will say. And I'm not even going to lie. A lot of times these will be on algebra tests in the future. And you get so used to factoring these multifaceted ones that you forget how to do the little ones. So I'm very glad to see that these continue to be on the worksheets because they will continue to appear, you know, in the years to come for you guys. So don't get so used to doing the bigger, fancier ones that you forget how to do just the very simple GCF ones. Okay. All right, so here we go. Worksheet number 2. Now, these are going to require us to look for greatest common factors or to do the slip, slide, divide, and bottoms up. So these are going to pull into some of our later factoring skills that we had. So on number 1, let's look at that. And there's a greatest common factor that will come out of that. Each term is divisible by a certain number. And what number is that? Anybody have a guess?
2.
2. Good job. So, I'm sorry, it wasn't cooperating for a minute. Is pink better or is green okay? Is there one y'all see better than another? So you're going to take your 2 out all the way across. So 2 divided by 2x squared leaves us x squared. 8x divided by 2 leaves us a negative 4x. And negative 24 divided by 2 is 12. We'll set that equal to 0. And now we factor. We're looking for 2 factors that multiply together that give us negative 12, that when we combine them, do y'all like it when I make the x? Is that necessary? Is that important? Not important? I need some feedback.
I don't know because
It helps me.
in the last
It helps.
unit, I never used the X, but I don't know if I need it in this part.
Okay, well, the X that's just telling you the factors that you need. So I will continue to show the X for anyone that it helps. So I've got a -6 and a +2. Those multiply to give me a -12. But not everybody needs them, Grayson. So if you're not using them, that's perfectly fine too, honey. All right, so now I actually have 3 factors. And yes, even that too counts. It's going to be crazy, but it even counts, okay? Every factor. So I'm going to set each one equal to 0. Is that a true statement? Does 2 equal 0?
No.
No. So all you do is show it like that. 2 does not equal 0, but you still have to show the work because you don't want to leave. The reason for that is like we had number 13 just a few minutes ago. Right here, that we did need to set that. So it was a viable factor. So you just want to make sure that you're addressing every factor in the problem. Okay? So x equals 6 because we add 6 to both sides. X plus 2 equals 0. That's going to give us a -2 because we would be subtracting 2 from each side. So I have a final solution set of -2, 6. All right. Number 3. There is a greatest common factor here also. Of 4. So if I take a 4 out of 4x squared, it leaves me x squared. If I take a 4 out of 12x, leaves me 3x. And if I take a 4 out of 8, leaves me 2. So now I'm looking for, oops, sorry guys. Eek. I'm looking for 2 factors that multiply together that give me a 2 when I multiply them and a 3 when I add them. So that's going to be a +2 and a +1. So I have 4 and then x plus 2, x plus 1 equals 0. So 4 does not equal 0. X plus 2 equals 0. So that gives me x equals -2 because I would subtract 2 from both sides in order to get x all by itself. Is everybody understanding what I'm doing there? Or do you like it better when I show all my steps? Does it help? Just need some feedback. X equals -2, -1. All righty. On number 5, I'm going to look for a greatest common factor. And I know that 3 will go into 3x squared, and it will also go into 6, but 3 won't go into 7. So that's not going to be an option for me to pull out a greatest common factor. So I'm going to slip, slide, divide, and bottoms up then. So that's going to give me, I'm going to slide, and I'm multiplying by a 3. And I remember I always write that 3 down to remind me because I've got to divide later. So that's going to give me x squared minus 7x minus 18. So I'm looking for two factors that when multiplied together give me a negative 18, that when I combine them give me a negative 7. That's going to be negative 9 and positive 2. So that's going to be x minus 9, x plus 2 equals 0. But now I need to divide. And what do I divide by? 3. Because that's what I slid down and multiplied by 3. So I'm going to divide by 3 here, divide by 3 here. X, this particular one will become x minus 3. This one is going to be one of my bottoms up because it will not reduce to a whole integer. So I'm going to bottoms up. So that's 3x plus 2 equals 0. So now I'll take each of these factors and set them individually equal to 0. So x equals 0, and then 3x plus 2 equals 0. So I have 3x equals negative 2. Divide both sides by 3, and x equals negative 2/3. So I have a solution set of x equals negative 2/3. Sorry, guys. Negative 2/3, and x equals 3. How we doing?
Good.
Good? How we doing, Grayson?
Complicated,
It is?
kind of.
What got complicated about this?
Just so many numbers everywhere.
But remember, the factoring is the same exact thing as we were doing before. All we're adding to that is taking the individual factors and setting them equal to 0. Right?
Could you like, yes, ma'am. Could
Okay.
you scroll up like half an inch, please?
Like that?
Yeah, thank you.
Oh, no problem. I'll try to write smaller too. Maybe that'll help. I don't know if that'll help or not. It's still a lot of numbers. I got you.
Okay, thank
Mm-hmm. All right. So we're going to slide and divide because I don't have a greatest common factor. So I've got x squared minus 19x minus 20. I'm going to make myself a note right here that I slid and multiplied by 4. So now I'm looking for two factors that multiply together to give me 20, negative 20, that when I add them or combine them will give me a negative 19. Well, that's going to be a negative 20 and a positive 1. So then I've got x minus 20, x plus 1. But now I want to remember to divide by that 4. So then x minus 20 over 4 reduces to x minus 5. This does not divide into a perfect integer, so I'm going to bottoms up here. Remember, if it doesn't make a whole integer, you bottoms up, and you always have to reduce in some way, get it to its smallest form. So that's going to be 4x plus 1 equals 0. So now I take each of my individual factors. So nothing different here. All we did was factor, just like we've been doing for the last 6 weeks. We're just factoring. But then we're going to take each individual factor, set it equal to 0, and solve for x. So it gives me x equals 5. And then over here is a little two-step equation. Won't hurt you a bit. X equals negative 1/4 because you divide both sides by 4. I didn't show that, sorry. So now I have a solution set of negative 1/4 and positive 5. Any questions so far?
Still a lot of numbers.
Yes, it is. Not too bad, though. They're not hard numbers. Nothing about this is hard. They're pretty small numbers. You got it. All right. Let's get some help on this next one to make sure that you all have got this down. So, is there a greatest common?
Yeah, I think so.
Is there a greatest common factor for number 9? That's the first thing you want to check.
What is?
No, there
not.
isn't. There is not. So what would we do? What have we been doing?
2.
No. What have we been doing? What did we do up here? What have we done on
You subtract
5 and 7?
Oh wait, no, you slide.
Slide and divide. Okay. So we got x squared plus 7x, and then 6 times 2 is 12. So we slide by multiplying by 6. And now we'll look for 2 factors that multiply together to give you 12, that when you combine them give you 7.
3 and
What
4.
are those factors?
3 and 4.
Good job. X plus 4, x plus 3 equals 0. Now we want to divide. What are we going to divide by?
6.
6, because we slid down and multiplied by 6. So now we want to divide by 6. Well, 4 over 6 does not reduce to a whole integer, but it does reduce to 2/3. And 3/6 does not reduce to a whole integer, but it does reduce to 1/2. So you have to get it in its smallest form. So now we're going to bottoms up because it's still not a whole integer. So you've got 3x plus 2 and 2x plus 1. Then you take each individual factor and set it equal to 0. and you've got x equals negative 2/3. And then over here, you've got negative 1/2. So I have a solution set of negative 1/2. Technically, I think it should be the other way around, and negative 2/3, because I think negative 2/3 is smaller than negative 1/2.
It'll be fine.
All right. Is number 11 in standard form?
No.
No, it is not. What do I need to do to get it in standard form?
You divide by the greatest common factor.
No, the standard form means I'm going to have an x. Remember, standard form is ax squared plus bx plus c equals 0. So I'm going to have 3 terms on my left with a 0 on my right. Or a y. The 0 can be a y also to be correct standard form. So what am I going to do? What did I do on the last worksheet? What did I do? And if there was something on the right-hand side,
Sure.
I'm sorry?
Do you slide and divide?
No, not yet.
It isn't
get it-
different from squares, is it?
No, I have to have it in standard form. What did I do on the last worksheet? If I have something on the right-hand side and I need that to be a 0, what am I going to do? What's on the right-hand side of the equal sign? What is that?
5.
5.
Okay, good job. What did I do to get it over to the other side on the last worksheet?
Subtract it.
Yes, good job, Roger. I'm going to subtract 5 from both sides. And now I'll have a x squared term minus 14x minus 5 equals 0. Do you all understand now? Thank you, Roger. Good job. Do you all understand how that now is in standard form? I have an x squared term, I've got an x term, and I've got a constant. Does that make sense to you guys? Remember, you want this set equal to 0. So you need to get everything on the left. So there's a 0 on the right. Everything on the left, 0 on the right. Does that make sense? Good thing to write down in your notes to remind yourself if you need to. I feel like on the notes yesterday, on the very beginning page, at the very top, there were steps, and it says make sure your equation is set to 0. Could you make me a cup of coffee in the Keurig with one of the yellow K cups? Thank you. Oh, does that make sense? Do you all remember doing that on that? Look back at the other worksheet that we did just a few minutes ago if you need to. Well, remember when we were moving everything to the left and combining like terms and all of that stuff to make sure you have a 0 on the right? Remember that? See, on number 7, number 9, see how we were getting those to where they were having 0 on the right. Is that ringing a bell now?
Yes, ma'am.
0. Okay, good. I don't want to move on until you guys have that, because that's a pretty critical part on all of these solving quadratics. It's very, very, very important. Even when we move on by taking square roots and using the quadratic formula, all of those things, it's a requirement to have it in this standard form where you have a 0 on the right and you've got your equation on the left. That's very, very, very important. So write that in all caps, make yourself a note, bold it, underline it. It needs to be in standard form before you can start getting your solutions. All right, so now we've got it in standard form. So there's no greatest common factor, and we've got a leading coefficient that's greater than 1. So we're going to slide and divide. So we're going to slide down, multiply by that leading coefficient of 3. Make yourself a note to remind yourself, because you've got to go back and divide later. So x squared minus 14x minus 15 equals 0. So you're going to multiply what we're looking for, 2 factors that multiply together that give you a negative 15, that when you combine them give you a negative 14. What are those factors? What's going to multiply to give me a negative 15? And then
Negative
add to
115.
Good job. It's negative 15, positive 1, x minus 15, x plus 1 equals 0. Now we need to divide. Don't forget to do that. We're going to divide by 3 since we multiplied by 3. This term here will reduce to a negative 5. This will not, so we'll bottoms up. And then we'll take each individual factor, set it equal to 0. And that will give us our solutions, our roots. Oops. I kind of shortcutted you guys on that. I'm sorry, but I was running out of room. So it's x equals negative 1/3. But that gives us our roots, our solutions, our zeros, the solution set. So if I were to graph this polynomial, it would cross the x-axis at the points negative 1/3, positive 5. That's what the solutions are. Oh, number 13, it's a train wreck. It's a mess. It is not in standard form at all. So help me out. Tell me what I'm going to do.
Do you slide and divide?
I've got to get it in standard form before I can factor. It has to be in standard form first. The very first thing you want to do every single time is get it in standard form. That's why on that quiz, I asked you guys, what is the standard? Whoa, ugly M, Miss Sparks. What is the standard form? That's why I asked. You cannot do anything until it's in standard form. Here's standard form. It has to be in that form before you proceed to do anything else. So how do I get number 13 in standard form? Is there a 0 on the right-hand side? Number 13. Is there a 0 there?
No.
And how do I make that a 0?
Subtract 5x squared.
Thank you, Roger. You subtract 5x squared. Good job. Way to go, Roger. Awesome. Subtract 5x squared. Are we in standard form yet?
I would say yes, but probably not.
Okay. What would make it be in standard form? It's a very slight change. What do I need to do? Look at
Move it
standard
around.
form. I'm sorry?
You
Move
need to
it
add
around.
like terms.
We're not going to add like terms exactly.
Subtract like terms.
We're not going to subtract anything either. Look at the standard form and compare the two. What is the order? This was another thing that was on that take-home quiz where you were supposed to put polynomials in the standard form. This is always important. Always, always important in algebra. Compare this ax squared that's on the screen to this. What is different about them? What's
You need to switch places with the 8 and negative 3x.
Good job, Roger. That is it exactly. Way to go. You are rocking it. Way to go. So remember, when we're switching places, just like Roger has instructed us, you want to make sure that every term has a sign and every sign has a term. So that 3x is a negative 3x. So when it moves, its sign moves. And that 8 is a positive. So when it moves, its sign moves. And now it is in standard form. Does everybody understand how to get there? Are there any questions? It has to be in standard form. You cannot factor, you cannot solve unless it's in standard form. It is absolutely essential. Everybody with me?
Yes, ma'am.
Okay. So now we're going to slide and divide. So I'm sliding and I'm multiplying a negative 5. So now I have x squared minus 3x minus 40 equals 0. So I'm looking for two factors that multiply together to give me a negative 40 that when I add them, give me a negative 3. Anybody have a suggestion?
8 and 5.
Good job. 8 and 5. Which one will be the bigger one? Which one will be positive? Which one will be negative? I mean,
8
there's
will
a
be
better way.
positive. 8 will be positive and 5 will be negative.
Try again. Because I'm looking
5
for a
will be-
negative here. Huh?
5 will be positive.
Yes, because I'm looking for a negative 3. So when I combine a positive and negative, you find the difference and give the sign of the higher one. So that 3 is negative, right?
Okay.
Does that make sense? X minus
Yes, ma'am.
8, x plus 5 equals 0. So what did I slide down? I multiplied by a -5. So now I'm going to divide by a -5. So that's going to, this does not reduce to a whole integer, but I am going to bottoms up. But this -8 divided by a -5 is going to change that middle sign to positive. So it's going to be 5x plus 8. And then 5 divided by a -5 is x minus 1. So now I'm going to take each individual factor. Set it equal to 0. And solve for x. So I have a solution set of -8/5 and +1. All right, number 15. What am I going to do first?
Put it in standard form.
Good job. Good job. Way to go. So how do I do that?
You divide it.
Nope.
Slide and divide.
Nope. That's factoring. To get it in standard form, 90% of the time to get something in standard form, all I'm going to do is move terms to one side. So I'm just going to be using inverse operations. So I just need to get my 17x to the left-hand side and my 5 to the left-hand side. So how do I do that? Can I just move them? Roger, are you still with me?
Yes.
What am I going to do?
Subtract 17x and 5.
Yes, subtract 17x and subtract 5 from both sides. Is that confusing if I do it at all one time for everybody? Is that, hello?
Yeah, that is kind of.
That's too confusing? I need to do it one at a time? Okay. I need to get 17x and the 5 over to the other side. So I'll subtract 17x. So now I have 12x squared minus 17x equals 5. And now I need to subtract the 5 because I'm trying to get a 0 on the right-hand side of the equation. Was that better, Grayson?
Yeah, but to get it in standard form, you're subtracting the 17 and moving it.
Yes, just like we did on the other worksheet. That's all we did on the other worksheet too. To move things from one side of an equation to another side of the equation, you just use the inverse operation, just like we talked about on the other sheet. You just moving it from the right side to the left side, you just use, so there's a positive, understood positive in front of the 17x. And and so all you do to undo positive or undo addition is subtract. Just like this is just regular standard algebra. Does that make sense?
Yeah, that makes more sense.
And now we'll slide and divide. So we're going to slide and multiply 12. So that's going to be x squared minus 17x minus 60 equals 0. So you think it's going to be 12 and 5, but it's not. So be careful. Those are not the factors. Because you think, oh, 12 and 5 add up to be 17. But I am looking for two factors that multiply to give me a negative 60 that add to give me a negative 17. So that means one is positive and one is negative. And it would require both of them to be negative if I use 12 and 5. So what two factors of 60, negative 60, multiply to give me a negative 60, but a negative 17? So that means I'm going to have one positive, one negative, and the bigger one is going to be negative, because when you find the difference, you give the sign of the higher one. So a big one's going to be negative and a small one's going to be positive. Does anybody know what they are? What are some factors of 60?
$30 and 2.
Good job. 30 and 2.
15
What's
and
another?
15 and 4.
15 and 4. We're getting close. What's another one? It's very similar to 30 and 2. Swap your 3 and your 2.
20 and 3.
20 and 3. Good job. So negative 20 and positive 3. Good job, Mary Faith. So x minus 20, x plus 3 equals 0. Now I want to divide. What do I divide by? What did I slide and multiply by?
12.
Good job. So I'm going to divide by 12. So 12 doesn't go into 20 evenly, but I can reduce that. And 4 goes into both of them. So I can reduce that to negative 5 over 4. And then the 3 over 12 reduces to 1/4. So you want to make sure you reduce them to their smallest fraction, but they're still not whole integers. So what do we do when they're not whole integers?
The first one would be 5x minus 4, and the second one would be x plus
No.
4.
Nope.
No.
What do I do?
Oh no, it'd be 4x minus
Yeah,
5.
what do I do? What's it called? What do I call it?
You need a bottoms up, maybe.
Bottoms up. Good job. Bottoms up. So when you think about that and it's bottoms up, when I'm moving that denominator is moving in front of the 4, in front of the x. So I'm going to have 4x minus 5. And then I'm going to have 4x plus 1 equals 0. So now I'm going to set each individual factor equal to 0. That was really messy. The computer had a huge delay. So my factors or my solutions actually are -1/4. Oops. I'm sorry. I did something wrong. I apologize. I divided by 4, and that should be a 3 there. So my apologies. I don't think I like writing with the green. So my solution set is -1/4, 5/3. So that's why I kept telling you guys all during the factoring unit, you got to remember all of your steps to factoring, because once we get to quadratics, then you've got to start remembering, you got to get it in standard form, and then you've got to solve each little factor. So we've added some things. Don't forget, put it in standard form first by using algebraic principles of inverse operations to get everything on the left-hand side and your 0 on the right. Or you can move everything to the right-hand side with your 0 on the left. That doesn't really matter. It's just what's really important is that you get it in standard form first, and then you factor, and then you solve each individual factor to find what your solutions are. And what do those solutions mean? Anybody tell me? What do those solutions tell us about the quadratic? Where it crosses what? If I'm graphing it.
Where it crosses the x-axis.
Good job. Way to go, Mary. It's where it crosses the x-axis. So those are its roots, its solutions, its zeros, its x-intercepts, where it crosses the x-axis. That's what we're gaining when we're solving these equations. Okay, so standard form has to be in standard form first. Any questions about today's work?
On Thursday's homework, are we doing a packet like this?
No, it'll be kind of it'll be more of the standard. It's not going to be 2 sheets of paper, but this was really only, typically we have anywhere from 16 to 22 problems. And today it was just 18. So it was still within the standard amount. It was just, this gave us a greater variety of factoring problems. And I didn't really want to spend 2 days factoring again, since we've been factoring for 8 weeks. So that's why I combined the 2 worksheets.
Thank you.
But yeah, you'll have you'll have I don't remember how many problems it is, Mary Faith, but it'll be about 16.
Okay, thank you.
Y'all have a blessed afternoon.
You too.
You too.
Thank you.
Thank you.